Good afternoon, everybody. Let's get started with the course. Welcome to MCEN 3017 Circuits and Electronics. I'm Bill Newhall. I will be teaching this course this semester. Today, I'm going to introduce the course. We're going to talk about the course format, some of the logistics, the assignments, and so take a look at the Canvas page. Canvas is up, and that's where you'll download your assignments and look for lecture notes. And there's actually the slides for this lecture and future lectures up there right now. If you would like to shout out a question during class, that's just fine. You can unmute and shout out. Otherwise, please keep muted so you keep the background noise low. If you want to talk to me after class, just stop by, stay on the Zoom session, and I'll start office hours right after class, and we can chat about class topics or whatever you want. If there's ever any technical problem, like my video drops out, audio drops out, class drops, um, just wait around. I'll get the class back up and we'll keep going. That hasn't happened yet in several years, so keep your fingers crossed there. Welcome. I'm teaching the class. I'm your instructor. I really enjoy teaching this class. I'm an electrical engineer by profession, and this class covers many electrical engineering topics from multiple electrical engineering classes. And I like to say we kind of took the best off of several classes to teach non-EEs. I'm sure most of you are mechanical engineers. Sometimes we get other engineers in this class, but it's really designed for non-electrical engineers and some very relevant topics when you're working with electrical engineers or just to understand the field at a high level. So that's what we're going to be doing. I think you should always know who your instructor is. So I wanted to introduce myself. So I specialize in radio frequency electronics, so high frequency electronics. I've been doing this since about, I don't know, 1995, so about 30 years now, developing electronics for RF systems and various systems, and being sort of a systems architect of electronic systems. And I enjoy teaching, so that's why I'm here. I enjoy teaching at the university and also teaching some topics in industry. And I work with mechanical engineers nearly every day. There's rarely a day I'm not interfacing with a mechanical engineer. So I think I've uh, taken enough surveys over the years to figure out what mechanical engineers that I work with, who I work with, want to know, wish they knew more about. And so we're going to talk about those topics. And my intent with this class is to leverage that experience that I've had over several years and to help you learn circuits and electronics fundamentals. Many of you may come into this class knowing the basics. You might have built circuits, made circuit boards, designed some circuits, or maybe not. Maybe you haven't done any of that. But either way, I try to make this class relevant to a range of experience for people who generally are not electrical engineers. So I'm going to try to use practical examples that are relevant to mechanical engineers, problems in industry or in academia or topics that you will run into in your career. So the goal of this course is to develop your abilities in analysis of circuits and design of circuits and in test of circuits, both analog and digital. And so what I like to do is start off with a survey. It's not really a survey. You don't have to respond, but think to yourself, do you have these skills as the foundation of what we will be talking about in the future of this class? So do you have any experience with electrical concepts? I think you do. If you've taken physics, you talked about charge, you probably talked about resistors and Ohm's law, capacitors and inductors. You probably talked about Kirchhoff's laws, right, in physics class. And we're going to review this, so you don't have to remember all the details about it right now, but going to review this material and then use it for some more advanced material. You've probably worked with or at least studied resistors, capacitors, and inductors. So from these basics, we're going to build upon them and talk about Thevenin equivalent circuits and phasors and impedance for analyzing AC circuits. You may have seen that, you may not have, but we will cover those definitely more in depth in this class if you did see those in an intro class. We're going to dive into electronics and electrical components like transistors and operational amplifier ICs and microprocessors. And we're going to talk about some other topics like at the end of the course, talk about sensors and how to apply these electronics. And all of this rolls up to improving and building your understanding of analysis, design, and test of electronics. So that's the big goal of this course. Again, mostly aimed at non-majors. Okay, so that's my email address. So contact me with any issues. My office hours are posted on the Canvas page. Generally, they're right after class. So you stick around on this Zoom session and we can chat about anything you want. We do have teaching assistants. They will assist us in lab. So you'll meet them in lab this Friday. They will be posting their emails and office hours on Canvas. So you can take a look at that. You can talk to any of us about anything, any homework problems, issues. We're all happy to help. Definitely join us and talk to us. The class webpage is Canvas, and the textbook is Hambly's Electrical Engineering Principles and Applications. So this book has several editions. We're using the 7th edition. It's important to have at least access to the 7th edition because there are several homework problems that will be taken out of the 7th edition and you will be working. So if you have the 6th edition or 5th edition or an international edition, right, even if it says 7th, if it's an international edition, you're not going to have the same homework problems. So the material hasn't changed much edition to edition, but the homework problems have. So be sure you get your homework problems out of the 7th edition. Okay. So the course format is this. We're going to have lectures and lab. So in lectures, I'm going to give you theory. I'm going to talk about the basics of the material, and we're going to work several example problems. So I will lead that. Quizzes will be given on the lecture material. They're basically take-home quizzes. Those are short questions on fundamental topics that are meant to prepare you for the homework and exercise your basic understanding, especially in the early part of the semester. So these will be concentrated early in the semester. Homework will be given, so you'll practice more complex problems compared to the quizzes. You'll have labs. We will work the labs in the ITLL lab. You're going to design circuits. You're going to construct circuits. You're going to use test equipment to test circuits. And the lab is structured so that in the beginning, there's a lot of sort of hand-holding to get you going on breadboarding and prototyping and measurements. And then as we get toward the end of the semester, you'll be doing a lot more on your own. And then all of this material wraps into 3 exams during the semester, exam 1, exam 2, and the final exam. And that will cover lecture and lab material. So the cartoon course roadmap looks like this. I like to divide the topics up into groups that represent sort of the classes that you would take in electrical engineering that cover these topics. So we're going to talk about basic electrical theory. What are circuit variables? Volts, amps, watts, right? Current, voltage, power. We're going to talk about basic analysis of DC circuits like Ohm's law, Kirchhoff's laws, voltage division, current division. That will be with DC sources. So these are considered DC circuits. Then we'll move on to transient circuits. Transient circuits are really transient analysis or transient responses. That's where you will have sudden changes in the circuit. So you're going to have capacitors and inductors in those circuits, and you're going to see how the circuit responds when you apply a sudden change in the circuit. That's appropriate for circuits like timers and analyzing circuits that have rapidly changing voltages. So you see how they respond. Then we're going to talk about analysis of AC circuits. So this applies to audio waveforms and radio frequency waveforms. We're going to look at circuits with resistors, inductors, and capacitors. We're going to use phasors and impedance to analyze those. So I think this is uh, a really good step to take for non-majors to understand how electrical engineers analyze these circuits. Then we're going to jump into what I consider the electronics part of the course. This is usually found in electronics classes in electrical engineering, like semiconductors, semiconductor circuits. We're going to talk about diodes and transistors and their applications. We're going to talk about operational amplifiers, and you will work with these in lab. And then we're going to move on to digital systems. We're going to talk about digital logic and digital systems. So combinatorial logic, how do you have a hardware circuit make a decision based on digital inputs? Okay, and then we're going to talk overall about analog and digital systems. We're going to move on to microcontrollers and talk about, well, when is it appropriate to use a microcontroller to sense and control a system? And when is it appropriate just to use simple hardware like combinatorial logic? We'll talk a little bit about software, how microcontrollers represent number systems, how microcontrollers perform math operations. So that's built into this part of the course. And then we'll finally connect to the mechanical world. We're going to talk about motors and servos, stepper motors, DC motors, servo motors, and the control loop that controls those. And then depending upon the time at the end of the semester, we'll talk about sensors and sensor circuits, and then some applications like voltage regulation. So we pack a lot into this course, try to take only what I consider to be the important material and cover it and get you familiar with it. All right, so our virtual classroom environment. So we're doing this remotely, and it's a big class. So but ask questions. If you have a question, you can unmute and shout it out, or shoot me a message in the chat. I have the chat window up, so you can shoot me a message there. Or stop by office hours right after if you'd like to talk about something in more detail. In fact, just because of the constraint on time, if it's a question where I say, well, we have to dig into that a little more, just stop by for a few minutes at office hours and we'll get right to that. So ask lots of questions. Contact me if there are any problems. You can't see something, you can't hear something, you can't understand me, my audio is bad, just anything. Let me know. If you're having any trouble with the class, getting to the materials, whatever, I'm happy to help. So for the lecture, you have plenty of online resources, Zoom, right? We're using Zoom for the lectures and office hours. That's where we have our live interaction. Canvas is up for distributing assignments and collecting assignments. The schedule is out there. I'll show you that. And lots of course info is out there. So you'll submit your assignments either by uploading a file or by filling out a form. You'll see that in the first lab, for the first lab and the first homework assignment and quiz. I use Slack to answer questions. So if you have any questions that you would like to email me, like beyond just stopping by office hours, or if you have to send me something to look at, I would ask that you post it or ask your question on Slack, because that way I can respond and the whole class can see it. So I can help many people who might have the same question. And so if you send me an email and say, hey, how do I do this problem? Is this right? I'll ask you to post it to Slack, and then I'll answer back there to you and everybody can see it. Okay, and be sure to, if you see someone needing help and you know the answer on Slack, go ahead and contribute. You might have a different solution, maybe even an easier solution than I have. So be sure to contribute and help others if you so choose. We're going to use clickers, so you're going to respond to questions during the lecture. And be sure to register for the circuits and electronics. I think if you search circuits or 3017 in your on your clicker account, you'll find this class. If not, stop by at office hours. We'll figure out how to get you signed up. Okay, and let me know if you're having any problems seeing or hearing any of this material. If you have any general audio or video problems, and let me know if the screen is out of focus on the whiteboard when we get to it, and I'll fix it right away. So for lecture, we're going to hold synchronous lectures via Zoom. We're going to cover circuits and electronics theory, work problems. We're going to first do a lot of slide work. I'm going to show a lot of slides in the beginning, and then we will switch over to a lot of whiteboard talks where I hope you take notes based on the whiteboard talks, or you can review the videos and do captures. But I will try to work the problems on the whiteboard so you can work along on your side. We'll have clicker questions, and all of these lectures are recorded. So it's going to include the video and the audio. So you can go back and review lectures. If there's some part you don't understand, I will index the lectures. You can go back to a particular part of the lecture if you want to hear that part again. There will be homework, and that's available on Canvas, and it's due as posted. So there's a due date and a due time on Canvas. So please be sure to submit a little early, right? Don't go past that due time, because just to be fair to everybody and consistent, there's a cutoff time, and you'll see that right there. So check that due time. And again, to be consistent with everyone, treat everybody the same. We're gonna I won't accept late homework, but you get to drop one homework grade. So if you miss it by accident, your grade doesn't have to be affected by that. And don't resubmit a homework or a quiz or anything after the due date or due time, because your original submission will get wiped out and your submission will show up late. And so then it's late. So be sure to, you can resubmit before the due time, but not after the due time. And then follow the instructions on the submission. You'll see the PDF files for the homework, and read that, follow those instructions. Also, working with others is permitted and encouraged. I encourage you to go out, work with people, find 1, 2, 3 people to work together, work a circuits problem, try to work them alone on these homeworks, talk about the solution, figure out if there's a better way. You might have a different way to solve a problem than someone else in your group does. So I encourage that, but in the end, submit your own homework. I think that's a great way to learn circuits, is to try solving it different ways. And if multiple people try to solve a problem, we'll have at least slightly different ways to solve a problem. Keep your supporting work for studying for exams. So you'll submit answers, but keep your supporting work, because the exams will have similar material to the homework. Okay, quizzes will emphasize the basics. So most of these quizzes are concentrated at the beginning of the course. There's one a little later in the course. Work these individually outside of class. They should be easy enough to, well, not easy enough, they should be straightforward enough to be able to work on your own. If you have any questions, definitely stop by office hours, post questions to Slack. Try not to give away answers on Slack, please. But helping is encouraged. But try to work these individually. And just like homework, to be consistent with everybody, I don't accept late quizzes, but one quiz will be dropped. And again, resubmission after the date or the due time will invalidate the earlier submission. So don't do that. The exams are will be posted on Canvas for you to work remotely. Those dates are on the website, so check out that schedule. Try to arrange any travel or vacation plans or trips around those. If you absolutely can't do that, contact me and we'll try to work something out. But these dates of the exams are pretty firm. If something strange happens in the course, we have lots of snow days or something like that, we might have to move it. But generally, I've kept those exams on those dates. Moving on to lab. So in lab, you will build and test circuits, and you're going to start with basic circuits that are more of a recipe, and then you're going to move on to designs and calculations of your own. You will work in teams of 3. So if you know who you want to work with, show up at lab and stick around each other. You can choose your own lab team. You're going to work at with a team of 3 at one bench, and so you can trade off building and measuring and designing for these labs. And I ask that you perform your design work during the pre-lab, so you have to do that anyway for the pre-lab, the calculations and some of the early work, because basically you're coming into lab to build and test. So try not to use that valuable time in the lab where you have the TA there, you have the test equipment there, you have your partners there all around the circuit. Try to not use that for design, but use that for build and test, do the design and calculations before. To fully use the ITLL resources, you have to take a 30-minute ITLL orientation. Okay, so do this prior to the first lab, which is in a couple weeks. So this Friday, you're going to have an introductory lab. You're going to form your groups, get some components, get your component kit. That's not lab 1. Lab 1 is not this Friday, but the following Friday. So before that following Friday, try to get in this 30-minute orientation that gives you computer access in the ITLL. It gives you extended card access hours, extended hours for that in the ITLL. And this is the website here. You can search the web for CU ITLL orientation. This page will come up. So in lab, you're going to be capturing data. Like this is the point of the lab is to build a circuit, show it meets the requirements, capture data to show it does that, capture some images of your circuit. So bring a USB memory stick for capturing oscilloscope waveforms. Okay, don't just take a picture of the screen because that's sometimes a lot of times that doesn't work out. We tried that. So bring a memory stick. You can do a screen capture from the oscilloscope. But do bring a phone camera to take photos of your circuits and take photos of your measurement setup. So that will be part of the material that you insert into your lab report. Lab attendance is mandatory, so you have 3 lab partners in a group. So everybody has to show up. You can't just send one person to work the lab. If someone has to miss the lab, I understand that happens. Then let's say one person out of the 3 has to miss the lab. That one person will either have to make up that lab and do a separate submission before the due date or work it early, or come up with an agreement with the team to work that lab at a separate time outside the lab period. Okay, but everybody's responsible for participating in the lab. There's pretty good test equipment available in the lab. Nice digital oscilloscopes, good probes, nice power supplies, function generators, some pretty good equipment in there. So that will be available to you in the lab. There's an electronics parts kit that has discrete electronic components and integrated circuits and breadboards. I'm trying to figure out if right now if this has to be purchased or not. In the past years, it's been purchased. I want to see if that's still the case. But these components are yours to keep for future projects should you choose to use them for a capstone project or some other senior project. Okay. Let's see what else about lab. So lab assignments, you're going to do a pre-lab, and that's where you're going to do your calculations that you prepare for your lab. And you go into lab and then you build what you worked on for your pre-lab. So work with your team members cooperatively in the design for doing the calculations and for answering questions for the pre-lab. So in general, every team should submit one solution. So a team of 3, one solution for the pre-labs, except for pre-lab 1, because we might not have the teams worked out completely then. So for pre-lab 1, work that yourself. Every other pre-lab going forward, you submit one solution. Please submit your write-ups, your submissions in Microsoft Word format or PDF if you can't get Word. So not another format, because that's what we open up to grade. And also please type your data into the Microsoft Word files, right? We've had problems in the past where people have tried to use a tablet and write in answers, and it was either unreadable or the format was bad, and it just didn't like pretend this is an example of of an assignment that you're going to show to an interviewer, right? When you're interviewing for an engineering job or a research job, and say, yeah, this is the kind of work I do. Make sure it's readable, looks professional. That's that's part of the assignment. The pre-lab is due as posted. Again, check the date and the time. And I ask that you don't just read the pre-lab. I'm sorry, don't just read. Don't just do the questions. Don't just try to skim through and answer the questions. Please read the pre-lab because the pre-lab really does guide you and it tries to speed your lab work up. It tries to make your lab work in lab more valuable because you'll concentrate on building and measuring and troubleshooting. There's a lot of information in the pre-lab that may not be covered in lecture. It's related to lecture very closely, but there's some specifics that we don't cover in lecture, and that's written out in the pre-lab. You will submit a lab report, and the lab report shows that you meet requirements. It's not a creative writing project, right? It's just you're entering data, you're entering figures, you're showing that you meet requirements and that your circuit works. You're going to record these measurements and again type these values in and insert photos and figures into the file. You're going to download this file as an assignment file. You use that as the template for your report. You enter in data into tables, or you describe something, or you insert a photo or a graph, and then that's what you submit to Canvas. Okay, so use your pre-lab work to start your design, and then if your initial design doesn't work, oftentimes it doesn't, you want to tweak it. Then in lab, you can tweak that design, maybe change a resistor value or a capacitor value. Then your design works, you've measured it. Then you include your final design in your lab report. So the pre-lab design doesn't have to equal your final design if you've done some tweaking to make sure you're within spec. Okay, and for the lab report, each team is going to submit one lab report. That's pretty much the case for all labs. Okay, and again, please use Microsoft Word format, or for some reason you can't submit that PDF format. In general, the lab reports are due 1 week from the lab period. So when you work, let's say lab 2, it's on a certain day. 1 week later, generally, that's when lab 2 is due. That's when your report has to be submitted. That morning of the following week, the following Friday. You're going to see that when you look at the assignments on Canvas, it shows, oh, lab 2 is due in the future. Well, your actual lab is executed 1 week prior to that. So keep an eye on the schedule that's up there because that's when you're actually performing the lab. But the due date is a week later, and that's what shows in Canvas. And then please submit your lab reports on time. There will be a penalty if you go past that date, that time. For grading, you have homework assignments and quizzes, 20% total. Pre-lab and lab reports, 20% total. And then each of the 3 exams is 20%. The lowest homework grade will be dropped. The lowest quiz grade will be dropped. Please use these grade dropping provisions for emergencies when you really want to save that for when you really have some kind of emergency or illness, or you just can't make it. So try to save those for when you really need them. Clicker questions will count as 1 homework grade. So what you have to do to get full credit for that clicker homework grade is provide an answer, right? Respond during at least half of the sessions where we have clicker questions. Okay, so if you answer at least half of those questions, you don't even have to get them right. If you answer, you'll get full credit. And if you get, half minus 1, right, no credit. So please participate in class. And if there's any issues with that, let me know. If you have any special need there. The lectures are recorded, so I like to do this so that you can review the lectures for people who may need to be remote for a week, or you have to go on a trip. You can watch the lectures then because they will be recorded. My goal is to make these easily available while respecting privacy, because this is a live class now that's recorded, and it does include the speaker video and the speaker audio. It doesn't. Oh, I don't know that it includes the video, but it includes what we're showing and my video when I show it and the whiteboard. But if you ask a question, the audio is captured there. So if you prefer not to have video recorded, I don't think it is, but to be safe, you can keep your camera off. I don't think it is, but if you prefer not to have your name shown in the videos, I don't think that's shown either, even when you talk, but you can list your name in Zoom. And don't show any identifying information if you don't want it included in the video. And if you really don't want to, talk on the video or discuss, I'm happy to talk as long as you want during office hours, and we can bring up the material again. So my recommendations for the course: see Canvas for the assignments and the due dates for those assignments, quizzes, homeworks, and lab. See the PDF schedule. I'll show you this. I'll bring up the Canvas site. I'll show you where this is. That has the whole course and the topics that we're covering during lectures, and when all the homeworks and quizzes and labs will be performed. So I recommend taking a look at that, maybe downloading that. I do update it occasionally. And if there's any major change, like an assignment change, I will send an announcement. If it's just a topic change, like we went late or we started a topic early, I might change that on the schedule, but I won't bug you with an announcement. There are videos. Take a look at those videos for review. Not only, let's see, I think there's at least one like tutorial video, and then I might post some more there, but the lectures will be there, the lecture videos. There are practice problems. So click on the practice problems link while you're working the class, while you're looking at homework, because what I do is I put some really tutorials out there, written tutorials that start with really basic problems and go up to more complex problems and walk through the solutions. So those are practice problems. There will be separate review problems for the exam that we'll talk about as the exam approaches. See the Slack page for questions, answers, and any tips I might post. I'll show you how to get there when we get to the Canvas page. And definitely work and discuss homework with others, either on Slack or remotely, and contribute. I recommend taking notes during the whiteboard talks and ask questions during class and office hours. So your upcoming assignments, you have pre-lab 1 coming up, quiz 1 coming up, homework 1 coming up. Check out the assignments page to find those. When you submit quizzes and homeworks, you're going to submit those. You click on the submit link, and you're going to see a form to enter your answers. It's going to look something like this. Make sure that you are logged in here. Make sure your email shows up here. Make sure your student ID is there. It's a backup for your email if something should go wrong. And then by default, I think I have it set up with every assignment, but just in case, make sure that you receive a copy of your responses by email. That is your receipt. That's like your stamped receipt for your homework. So that will, if for some reason it doesn't get into the response file, that will be your confirmation that you submitted the homework. And again, don't submit homework after the due time. The form will happily let you do that, but it'll show up late. Okay. So let's do a tour of Canvas. I'm going to show you a few things here. Let me bring up Canvas. If I can. I'm going to show you this, what I see. This is what I see in student view once I bring it up. Okay. Okay, so here's the Canvas page. I think this is what you see. This is my student view. So your view might be a little different. Click on the general information and Zoom links. If you got to the Zoom session, that's You might have clicked on this link here. Here's where we will list office hours of the TAs, and there's my email and TA emails there. If you, let's see, this is the PDF schedule file. So this has the lectures, the homeworks and their due dates, the quizzes, the due dates, the labs, when they will be performed and when they're due, when the pre-labs are due. Here are all the dates. So this is really the guide to what we're doing in this class and the dates of the different topics in lecture, things like that. So take a look at that. There's the cartoon roadmap that I showed you here, the Slack discussion. So to join Slack, you can click on this invitation link and join Slack. This is where you'll get to Slack after you join. That invitation link is probably only open for 27 more days. So if you want to talk with each other, talk with me on Slack, communicate on Slack, click on that link in the next couple weeks and join up so that that link doesn't expire. Let's see what else. So syllabus, there's the official syllabus here. Take a look at that. iClicker and iClicker grades. You're going to go to your iClicker account to look at your responses for clickers. And I think I even have, if you can't find the clicker on your account, I think this is the join link here. I haven't used it because I'm the instructor, not the student. So I click on it. It doesn't do what I think it would do. These are all the lecture slides. So here's today's introduction. We're going to start working on circuit variables, right? Here's in chronological order. These are the lecture slides that we will be covering. Here's the videos. Click on, there's no videos yet. This is our first video. Here are the practice problems. So when we get to node voltages and node voltage analysis, you might take a look at these. And then this is lab information. Here's the lab orientation link. All the data sheets that you might need in lab. Here are the solutions that don't get posted until after the due date. And then we'll have a review down here for exams. If you look at the assignments, click on assignments, you'll see, I like to order by type so I can see all the quizzes and all their due dates, all the homeworks and all their due dates, right? And all the labs. Okay, so that's where you can find those. You can check grades. The grade calculations in Canvas are weird. I have it set to like drop the lowest grade or count missed assignments when there's no grade as 0, and Canvas doesn't seem to be handling it right. So you got to really, I calculate the grades with a spreadsheet at the end of the semester, compare them to what I see, and so take the grade you see in Canvas with a grain of salt, the roll up grade. Okay, so that's Canvas. And all the logistics of the course that I want to cover today. And so someone asked in the chat, are exams in person or online? Exams will be online. So exams will generally be during the class period plus 30 minutes. So 4:40, the exam will be issued. You work the exam. You're going to have 30 extra minutes just in case like there's any issues with submission, but you'll work those on your own remotely and then submit your exam. Okay. And exams are open book, open notes, open MATLAB, whatever you want. Yep. And the textbook. So I just signed up for something through the university. I forget what it's called, where the textbook is available through some program. I don't know the answer to that. I have a hard copy. You might, I think it might be CU Book Access. Check it out. Let me know what you find. I'd like to know myself how the book is available to you. I see how it's available to me, but not to you. So, okay. Sign into CU Clicker with your CU emails, yes. So the first pre-lab, you'll see where it's due. Click on so right here, let's go down to pre-lab. The first pre-lab is due January 23rd at 11:59 p.m. That's the day before the lab. Okay. Okay. All right. So So if you have any questions about the logistics, stop by office hours and we'll work through that. And what I'm going to do now is let's jump into the real material of the course. Start talking about that. Let's get my screen up here. Okay. So we're going to begin talking about circuits and circuit variables. Okay. And let's define what circuit variables are. But first, I want to back up and talk a little bit again about why you're learning circuits, why it's important to learn circuits. It's because electrical circuits now in modern engineering are part of many engineering problems, engineering solutions, engineering research. You're going to find circuits everywhere, whether it's part of the project or product you're building, or just sensors or supporting circuits to do measurements or to do monitoring of the project or research. Okay. And I like to say this, I like to say not having an understanding of basic electrical concepts like voltage, current, power, having a feel for those. I think that can be as restricting as not having an understanding of basic mechanical concepts like mass, force, and velocity. And the example I like to give is imagine you're joining an engineering team, right? And you're building, I like to use a drone as an example, some kind of like, drone application. And and you have some requirements for that application. And like, let's say I'm the electrical engineer and I'm just only electrical engineer. And I'm not, I don't know that mechanical engineering stuff. And, I think that I should have some at least basic understanding of these basic mechanical concepts like mass, force, and velocity, right? If the drone has to, for example, if the drone has to fly, 20 miles an hour, something like that. Okay, I can understand that 20 miles an hour, that seems reasonable. If I say the drone has to fly 2,000 miles an hour, be like, you're going supersonic there. That might be a problem. That's a more challenging problem. But just to be able to understand, well, 20 miles an hour versus 2,000 miles an hour, it's like understanding, well, 20 milliamps versus 20 amps versus 2 mega amps, right? So you want to kind of have an understanding of these basic electrical concepts so that you'll know if values are reasonable, and you'll know this, you'll understand better the scope and the effort of a project that you're working on, right? So that's just a simple example, but I think it is important to have an understanding of these basic electrical concepts, just like many people have an understanding of basic mechanical concepts. This will help you work with electrical engineers. It will help you work on electromechanical systems. Eventually, you'll be leading engineering teams. It'll help you communicate with the multiple disciplines within your team. And so, that I think all that's important. Okay. And eventually, this will let you have a bigger impact on what you're working on and give you a larger systems knowledge. All right. So why do we use circuits? What do we really use circuits for beyond homework problems, right? What you're going to see is that we generally use circuits to do work. Okay. It's not very specific. Let me get more specific. When you do work using electrical circuits, you're doing one of two things typically. You can divide roughly up into these two areas where you're doing work. Like you're either delivering energy, right? You're lighting something, you're heating something, you're moving something, right? You're delivering energy from one place to another in order to do work, right? So that's one way to think of why we use circuits. Another application of circuits where you're doing work is representing information. And this isn't as obvious, right? You send an email, are you doing work? Well, yes, you are. When you send a bit across a wire, right? Or you send a bit even over the air, you're sending energy. When you send energy over time is work. It's joules, right? You're delivering power. So when you sense, when you communicate, when you store in memory, and when you control, that all takes energy. you're delivering energy, you're doing work, okay? But fundamentally, you kind of think about these differently, right? When you're moving something with an electric motor versus storing something in memory, those seem different. But in both applications, you're using an electrical circuit to do work. We're going to talk about schematics, and I like to use this cartoon. I think this is out of the book, to talk about the electrical circuit that you actually see versus the schematic that represents that circuit. So here's an electrical circuit in a very old car that has a battery and two headlights and wires connecting the battery and headlights to a switch, right? That's the physical cartoon drawing of the actual circuit. When I talk about a schematic, I'm talking about extracting only the relevant electrical information from that physical circuit and representing the electrical characteristics in this schematic. So here in this schematic, you have circuit elements. So when I say circuit elements, I mean, a voltage source, a resistor, a switch. Those are the circuit elements. Excuse me. When I talk about the connections, I'm going to talk about the conductors. We're going to call those nodes eventually. So when I say schematic, think circuit diagram, where the electrical characteristics are represented. So the physical lengths, the physical sizes, the shapes, the placement of the components, the orientations, they are not generally represented in the schematic. Now you could put special notes in there. You could talk about components being close to each other. That's done sometimes. But in general, when you're looking at a textbook schematic, the vertical versus horizontal or the placement of the components doesn't have to be in the exact order shown in the schematic. Okay. So when you think schematic, think circuit diagram. So this course is all about working with these three values: current, voltage, and power. These are called circuit variables. You're going to calculate these values for these variables. You're going to measure these values. You're going to design for these values. And you're going to see these apply to all of the topics we cover, including voltage and current sources, Thevenin equivalent circuits, sinusoidal analysis, for example, audio signals, right? Transistors and op amps in common electronics, digital circuits and motors. Voltage, current, and power are all important quantities and essential quantities. You're going to do calculations for these in each of these topics. So let's talk about the first circuit variable that I like to talk about, current. Current is the flow of positive electric charge. The units are amps. You might see milliamps, microamps, nanoamps. So let's suppose you have a wire. So here's a wire, and I do something to cause electrons to flow from right to left. Well, current in electrical engineering, unlike many physics areas, we define current to have a positive or to be the flow of positive charge. So if electrons are going right to left, positive charge, net positive charge is going left to right. So the current, positive current, is going left to right. So if you define Q of T to be the charge through the cross section in units of coulombs, like Q represents charge in units of coulombs, and it can change over time. The amount of charge through that cross section can change over the time as current is flowing. Current is the derivative of charge for with respect to time, right? So I of T is current, and dq dt is how you calculate current given charge. And that current has units of amps or coulombs per second. If you look at the derivative, right? Q is coulombs, T is seconds. That's coulomb per second. We call it amps. So current always is defined using a reference direction. So if I have a wire, so here's a wire, and I label 2 points A and B, and I have current flowing from A to B, I can define that current. Let's say it's 2 amps. I just happen to know it's 2 amps with a reference direction. This arrow is the reference direction. 2 amps is the quantity of current. Um, the arrow is the direction, the reference direction for that current. Okay. And so what we'll do is we'll talk about this more next time. Like, what does it mean to reverse that reference direction? Or what does it mean to have negative current flow? You can do that. You can have a negative 2 amps. What does it mean to have to use the notation like double subscript notation? We're going to talk about that next time. But this gives you an intro into what we're going to talk about. All right, so I've hit the end of class for today. So in closing, thanks for joining the class. Thanks for signing up for the class. Be sure to check out the assignments on Canvas. Those are posted. Check out that PDF schedule file. See the Slack invitation link. So click on that invitation link within the next 26, 27, 28 days, because that will expire. So please do that. Let me know if you have any issues, if you have any problems, seeing anything, hearing anything. Stop by, let me know. I will start office hours in just a few seconds. So if you'd like to talk about class material or anything, just stay on this session and we'll talk. If you don't join, I'll see you next time. Have a great night.